In this video, I will go over problems that are related to trigonometric functions. First, let's look at question number 1. Here it says we have a function which is fx is a cosine omega s x plus pi over 6, and this is the approximate shape of its graph. It's defined from negative pi to pi, and the question is, based on the information that is given in the graph, what is the least positive period of fx? Okay, so first of all, let's recall the graph of sine function. Right? So we know if we have a regular sine function, so let's say this is theta, and this is cosine theta. The period is 2 pi. So it starts from here and goes to 2 pi, right? So let's say 0, and this is 2 pi. Okay, now if we look at the graph, we can see several things. Number one, if we look at the period, right? If you look at its positive period, this here is from pi negative pi to pi, so there's 2 pi, but obviously it contains more than one period of the graph. So we know the period is less than 2 pi. And meanwhile, if you look at from 0 to pi, it's only have this -1, but it hasn't go back to the +1. So it hasn't finished one period yet. Okay, so then we get a period that has to be bigger than pi, but less than 2 pi. So that's the first piece of information. Second, if we look at, say we start from 0 here, right? And the function is decreasing. If you look at the graph of cosine, we know cosine theta from 0 to pi, the function is also decreasing. And this tells us what? This from here, we can derive this omega, right? So here, this is x equals 0. So we know the omega has to be positive, right? In order that near the x, the function is from 0 to in this direction, right? If you go increase from 0, the function decreasing. Okay, so here we have omega is positive. Okay, all right. So the second piece of information is omega positive, and from here we know the least positive period equals 2 pi over omega, right? 2 pi over omega. Okay, so now the question is, what is the omega? Okay, in order to find that, we use there's another information here. It says this one tells us, right? So the f evaluated at -4 pi over 9. So this is the point 4 pi over 9. So f evaluated of -4 pi over 9, this one equals 0. Okay, from here we can just plug into. So I get a cosine omega times -4 pi over 9 and plus pi over 6, right? Now, because the period is between pi and 2 pi, and we know the least part of period is 2 pi of omega, so from here we can also derive the omega is bigger than 1, but is it's bigger than 1, but is less than 2, right? It's bigger than 1, but it's less than 2. So okay, all right. So based on that, and we know this one equals 0, so combine this with that. Okay, so then because the range of pi is between 1 and 2, and this one cosine 0, so okay, so combine this information, we know this one can only be -pi over 2, and from here we can quickly solve the omega equals 3 over 2, and therefore the least period 2 pi over omega is 4 pi over 3. Question number 2. Here the question asks, for how many t the function fx equals sine x plus cosine x plus t is an even function of x. Now, even function means, by definition, even function just means fx is the same if we replace x by -x. There are different ways to solve the problem. The quickest way is to try a special value. So let's try. Okay, so if we want to try special x. Now, what are those special x to try? Usually we use those angles where sine or cosine attains its maximum or minimum, right? For here, we say, okay, we can try x equals pi over 2. So we have f pi over 2 equals f -pi over 2. So what is f pi over 2? So we just, we have pi over 2 equals here. We know the sine, okay, let's recall the sine pi over 2 is 1, right? Okay, so then this is just 1 plus cosine pi over 2 and plus t, all right? And this equals sine. Now, what is sine? Negative pi over 2. Now, sine function is odd function, right? If we look at the graph of sine, so sine function is odd function. So this is sine theta, right? So theta sine theta is odd function. So sine negative pi over 2, this is negative 1. Okay, so then what do we have? It's just negative 1 plus cosine that negative pi over 2 and plus t. Now, if you combine them together, we just get 2 equals cosine t minus pi over 2 and minus cosine pi over 2 and plus t. Okay, now if we look at cosine function, we know cosine function is always between negative 1 and 1, right? So this is always between negative 1 and 1, always between negative 1 and 1. Now, in order for this to combine to be 2, there's only one choice. This one is 1, and this guy equals negative 1. Okay. Now, we know the t is it's between, right? So t is between 0 and 2 pi. In order for this to be 1, this negative 1, there's only one choice. We say, okay, so t has to be pi over 2. So the point is we get if the f is even function, t has to be pi over 2. Okay, so this is if f is even, implies t is pi over 2. But we need to check whether the converse is true. If t is pi over 2, whether the f actually is even function, right? If the answer is yes, then we have 1t. If no, then answer is 0, right? All right, so let's check. If t is pi over 2, we just get fx equals sine x plus cosine x plus pi over 2. Now, we need to use trigonometric identity. So what is cosine x pi over 2? Cosine x pi over 2 equals sine x, but you should put negative sign. Okay. Now, if you're not sure whether it's plus or minus, so first of all, we know this is cosine x plus pi over 2. So it's order multiple pi over 2. So you have to change from cosine to sine. So this is what we know. And the subtle thing is whether plus or minus. If the plus or minus, what you can check is you can use a special number. Say you can just use x equal to pi over 2 to plug into here, right? If x equal to pi over 2, this is 1. And this is sine at cosine, right? Cosine x pi over 2, so you just get a pi, which is negative 1. So that's why you have a negative sign. Okay, so the point is this equals to negative sine x and x, if they combine, so you just get a sine x minus sine x, which is constant 0. So the point is, if t equals pi over 2, we get our function fx is constantly 0. It's constant 0. Of course, it's an even function. So the answer is 1. There's only one, which is t equals pi over 2 between 0 and 2 pi. Question number 3. So here says x is accurate angle. Accurate angle means x is between 0 and pi over 2, right? Or if we use degrees, that means 0 and 90, right? So here I use the radian. Okay, so we know cosine 2x over cosine x is negative 1/6, and sine x or sine 2x or sine x n over n. Well, basically, you need to figure out what are m and n. Here we see cosine 2x and sine 2x. So obviously, we should use the double angle formula. So let's recall the double angle formula. Angle formulas. So first one, we know the sine 2x equals sine x, 2 sine x times cosine x. And number 2, if it's cosine 2x equals 2 cosine x squared minus 1, or if you use sine, then this is 1 minus 2 sine x squared. All right. So here, of course, we use the basic effect, sine x squared plus cosine x squared equals 1, right? Okay. Now, so from here, if I use sine 2x equal 2 sine x cosine x, I will get this one is just equals to 2 cosine x. Okay, so this one is just equals 2 cosine x. Therefore, in order to find n and n, basically, we just need to find what is cosine x. Okay, so how we find cosine x? We use this formula and plug into here, all right? And this gives us cosine 2x over cosine x equals, apply this double angle formula, 2 cosine x squared minus 1, and over cosine x equals negative 1/6. When we look at here, we know this will, after we simplify the expression, this is going to give us a quadratic equation of cosine x, right? Of cosine x. Now, for convenience, I just let t to be cosine x. And then, okay, so that means this one, it will just be t. and this guy is just equal to t squared. Okay, and this gives us a quadratic coefficient of t, which is 12 t squared and plus t minus, and then it's plus minus 6, and we get is minus 6 equals 0, right? Minus 6 equals 0. And this is a quadratic equation. All right, to solve the quadratic equation, either we just use the quadratic formula or we can simply factorize this. So here we can simply factorize it. All right, so we have a 12 is 4 times 3, and 6 is 3 and 2. If I put negative, right, so I have 9 minus 8 is 1, which takes that here. Okay, then we just get 3t minus 2 and 4t plus 3 equals 0. And this tells us t equals 2 over 3 or t equals negative 3 over 4. However, we know that x is an acute angle. If it's an acute angle, the cosine, this one is always positive. Therefore, this one is not valid. What we finally, we just get t equals 2 over 3. Okay, and n of n is twice of cosine x, so this is twice of t, which is 4 over 3. Accordingly, this guy is m, and this guy is n, and m plus n equals 7. So the answer is A, 7. Question number 4. The problem says we have a point A, which is 2, 0, that is on the coordinate plane. And we have another point P, its x coordinate, given by the expression sine 2t minus 60, and its y coordinate, it's the cosine 2t minus 60. So as t changes, the point P is moving on the plane. Right? And then we connect the line AP, and we look at the region that is passed by the line, and we'll find its area. Okay, first of all, let's identify where the point P is. Okay, so here we have the x coordinate is sine 2t minus 60, and y is cosine 2t minus 60. So it's a sine and a cosine of the same angle, let's say theta. And we have the basic equality, right? Identity. So sine theta squared plus cosine theta equal to 1. So that means for P, it's x squared plus y squared is always 1, regardless what t is. And this tells us the P is on the unit circle, right? So that means it's on the unit circle, all right? So let's draw the circle. This is the unit circle, with radius 1, right? Okay, now let's look at a P. If we start from, say, t equals 15 degree, and for this case, the P is sine 30, negative 30, right? So we have P. Okay, so we have the P equals sine negative 30 degree and cosine negative 30 degree. Now sine, as we said before, sine is order function. So this is negative sine 30 degree, we know it's 1/2, right? So the special angle. So this one is negative 1/2. And this is cosine is order function. So cosine negative x is cosine x, and sine negative x is negative sine x. Okay. All right. So this is square root over 2. Okay. So this is our P. Let's put it here. So this is the point of P when t landmark. So this t equals 15, right? T equals 15. Okay, now let's look at when t is 0. Okay, 15. When t is 0, so if t is 0, we'll get the P, the point of P, right? So P not 0, it's 30, because 30 is middle. Okay, so if P, then P is equals to a sine 0, right? And cosine 0. Now sine 0 is 0 and this is 1. Okay, so then this is the P when the t equals 30. And then if t is the last one, which is 45, right? So if you look at t is 45, then we just get the P is sine 30 degree and cosine 30 degree, right? Cosine 30 degree, this is 1/2. This is square of 2, so it's right here. Okay, all right. So this one will be just t equals 45, and then you see this is the trajectory of P. So P moves from starting from this point to here. Let's connect the point P, the A. That's what we have. And this is the region that is passed by all the lines segment AP, and we find its area. When you look at this region, the region is not a sector or not regular shape. How we find the area? So what we do is cut and paste. If we combine, we say, okay, so if we combine this region with this triangle, right? So if we combine them together, what do we get? We basically just get this sector, right? So part of the sector and plus another triangle, right? Plot another triangle. Now, for the sector, you need to find the degree. Because this is square root 3/2, this is 1/2, then we quickly get this one is 60, right? So this guy is 60. So this is 30, this is also 30, and this is 60. All right. Okay, so then we get the area of this sector is 1/6 of the whole thing. So it's 6/pi. So that's its area of the sector. If you look at this triangle, right? If you look at this triangle, P and P, so this one, these two P's, and if you compare, the height is the same. If you look at the height, and it's the height is the same as the other one. So my point is, if we consider this is 1, this is 2. So 1 and 2, these two triangles, they have the same area. So we say, okay, 1 equals 2. They have the same area. That's because you can calculate, or you can say they share the same base, and also they have the same height. Okay, so as a conclusion, we just get the green part. So we get this one equals to the green part in areas, right? That's because the green one plus this triangle equals this the sector plus the triangle, and these two triangles, they have the same area. Therefore, this green region has the same area as the sector. So the answer is pi/6. Question number 5. In triangle ABC, we know the sine value of angle A and the cosine value of B. And we know that all the side lengths are integers. The question is, what is the least possible value of its parameter? Okay, so this is a typical question to apply some important trigonometric identities. So here what we have is the sum formula, and also we have important theorem like the law of sine. Okay, all right, so here we have the sine A is 3/5 and the cosine B is 12/13, and we have recall this important and basic identity. So from here we get a sine B equals 5/13. Now, because ABC are angles, we need triangles, is always between 0 and pi. Here I'm using radian, and therefore the sign is always positive. So we don't have to consider the negative one. All right. And then we say, okay, we can figure out sine C, because C equals pi minus A minus B, right? Here again, I'm using radian. Okay. So then we have the sine C equals the sine pi minus A plus B. And then we recall trigonometric identity for sine. We know sine pi. Okay. So if we recall, it's sine pi minus theta. This one is the same as sine theta. Okay. So, and this one is just sine A plus B. Now we use the sum formula, right? Sine A plus B equals, so let's review, let's recall this. This one sine A times cosine B and plus cosine A times sine B. All right, let's see what do we have. We have sine B, this is 5/13. This one is 3/5. This one is 12/13. And what we don't know is the cosine A. Okay, but we have the sine A equals to 3/5. And we can get a cosine A. Again, use this sine theta squared plus cosine theta 1. Now, when we go to cosine within a triangle, we should be careful because cosine could be positive or negative, right? When it's positive means A is acute angle, but it also, so this is the case cosine A is positive, but you can also have a case that A is it's obtuse, right? So for this case, which is possible, the cosine A will be negative. All right, so the point is we have two possibles. One is 5/3, 4/5, and the other one is negative 4/5, right? Okay, so case one. If cosine A equals 4/5, and then we'll get the sine C will be 13/65 plus 20/65. So what we get is 56/65, right? We get a 65, right? And that's one. Now, and the other one, for this case, and we have the other is sine A equals 3/5, sine B equals 5/13. Now we recall the law of sine, right? Law of sine. So law of sine says A over sine A, the corresponding sine, right? So A over sine A equals B over sine B equals C over sine C. So here is the sine. This is A, this is B, and this is C, right? So from this law of sine, we say, okay, for case one, we'll just get that the ratio between those sides is everything you change to 65, and this will be just 45. Hold on. So this will be 39, right? So this one will be 39. This, if you change this, change to 65, right? So this will be 25. 25. Okay, so then what you have is 39, comma 25, and comma 56. The least. Then the least, if they are all integers, right? The least sum or least parameter will be 39 plus 25 plus 56, right? Okay, now, but this is not the least possibility. We can look at, let's look at case two. Now, if to case two, the cosine A equals negative 5/4, and for this case, we will get sine C will be 36/65 and minus 20/65, so you get a 16/65. Again, by law of just by law of sine, we'll just get A comma B comma C, right? A comma B comma C, and this equals to this C. Okay, it's 39, right? 39 comma 25, but C is becomes 16. Now, then for this case, the sum becomes the parameter, right? So the parameter becomes 39 plus 25 plus 16, and we get is 80. Now, obviously, 80 is less than the previous one, right? The case one is acute angle. All right, so it achieves, the parameter achieves the least value when we have this obtuse one, right? And the answer is 80. Question number 6. This is again a problem regarding angles within a triangle. So we have a triangle ABC, the angle C equals 60 degrees. Angle A is bigger than angle B. Now what we know is the sine A plus sine B equals 1. And the question is, okay, what's the cosine A minus cosine B? Now, the point is if we know the information on sine, and how can we transfer the information from sine to cosine? A common way is like what we see in previous problems. What we have is, again, we just use this basic identity. Sine theta plus cosine theta equals 1, right? So we take the square and we sum them up, and we expect to get things which are nice. All right. Okay, so we have sine A plus sine B equals 1. And we are looking for cosine A minus cosine B. Let's say we put this guy as X. And we take the square of both identities and we sum them up. So from here, we get a sine A plus sine B squared equals 1. And cosine A minus cosine B squared equals X squared. Okay, and then we add them together. Okay, all right. Now, we write things out. The first one, what we will get is sine A squared, right? Plus twice of sine A plus sine B and plus sine B squared equals 1. The second, what do we get? the next one we get is cosine A squared, right? Minus twice of cosine A and cosine B and plus cosine B squared equals x squared. Okay, now when we sum them up, these two add up equals to 1. These two add up is also 1, okay? And this gives us, it's 2 plus 2 times sine A, sine B, and minus cosine A and cosine B equals 1 plus x squared. All right, now we still have these mixed terms, right? Sine A, sine B, cosine A, cosine B. But when we look at the form, it's sine times sine minus cosine times cosine. So this looks like the sum formula or the difference formula, right? Let's recall the difference formula. So if we have the sum formula and the difference formula of cosine, okay, so let's recall, because this is sine, cosine, right? So let's recall the formula. So cosine, say alpha plus beta. This one is cosine alpha, cosine beta, minus sine alpha, sine beta, right? It's minus. And if it's cosine alpha minus beta, then it's cosine alpha, cosine beta plus sine alpha, sine beta. Now, sometimes if you forget whether this is plus or this is minus, you can just choose special angles to try it, right? So here you can choose alpha equals beta equals 0. And then you can determine whether it's plus or minus. Okay, so then based on this, we have this minus, right? So here we have this sum formula, so this is for cosine. Then we get it twice, minus twice cosine, this is A plus B equals 1 plus x squared. Now, what is A plus B? Because we know C is 6 degree, right? So that's the place we use C is 6 degree. We get this guy is 120 degree. Okay, what is 100 cosine 120? This is special angle we need to memorize this guy. So cosine 120 is negative 1/2. So cosine 60 is 1/2 and cosine 120 is negative 1/2. All right, and then this gives us is negative 2 negative 1/2. Okay, so 2 times negative 1, so you get together and up you get 3 equals 1 plus x squared, and this gives us x squared equals 2. Now, if x squared equals 2, then we have two choices. Either x is square root 2 or it's negative square root 2. Let's go back to the problem. The problem says the angle A, because the angle A is bigger than angle B. And we know cosine function. The cosine function is decreasing from 0 to pi, right? Let's recall the function. So this is theta and cosine theta, so 0, and here's pi, right? The function is decreasing. Okay, so if cosine, if A and B, because A, B, C, they're all angles with a triangle, so they're between 0 and pi. All right, so from here we know, okay, so cosine A is strictly less than cosine B, so that means the x has to be negative the square root of 2. Question number 7. Here we know sine alpha minus cosine alpha equals 1/5. For sine alpha between 0 and 180 degrees. So here we use the unit of degrees. The question is, what is tangent alpha? Now let's recall, tangent alpha by definition equals sine alpha over cosine alpha. All right, so basically we just need to figure out what is sine alpha and what is cosine alpha. Here we have one equation tells us the relation between sine and cosine, and also we have the identity. Cosine alpha squared plus sine alpha squared equals 1. So this is universal identity. All right, and this tells us we can just replace, say we want to find the sine alpha first. We can just replace the cosine alpha, right? So cosine alpha equals, this is sine alpha minus 1/5 squared. And if we write out, we get a quadratic equation of sine alpha. Okay, for convenience, I'll let t equals, let's say x. Okay, so if I let x equals sine alpha, and then this will give me the equation, which is x squared plus x minus 1/5 equals 1. Now we write out and we simplify coefficients. Eventually, we just end up with, okay, so we get a 50 x squared minus 10x and minus 24 equals 0. All right, and then we divided 2 on both sides, got 25x squared minus 5x minus 12 equals 0. Okay. Now, this is a quadratic equation. We can either use quadratic formula or again, we can use factorization. Let's use factorization. This is 5, 5, 25. Here we get negative. So this is negative 4 and 3. Okay. Then we can have is 5x minus 4 equals 5x plus 3 equals 0. Now, from the equation itself, we get two solutions, right? Either x equals 504 or x equals negative 305. But this one is not valid. Why it's not valid? Because our alpha, yes, the problem says the alpha is between 0 and 180. If we recall the graph of sine x, so this is sine x, right? Theta and sine theta, right? Sine theta function. Between 0 and pi, this function, this is non-negative, right? Non-negative. Accordingly, from here, we find that 405, this is the only valid solution. Okay, then we can able to, if this I know this guy is 405, now I get a cosine 1, this will be just 3 over 5. And we put this 2 back to here, we just get tangent is 4 over 3. Question number 8. Here we need to find the number of x in radians from 0 to 2 pi such that this trigonometric equation holds. So cosine 4x equals cosine 7x. First, let's recall. If I have two angles, alpha and beta, if I know that cosine alpha equals to cosine beta, what can you say about the relation between alpha and beta? Well, if we see the graph of the cosine function, right? First of all, of course, it's 2 pi periodic. And also, if you see, if we have this is alpha, this is 2 pi minus alpha, then the value of cosine is also the same. So cosine alpha equals cosine 2 pi minus alpha. All right. Okay, therefore, if cosine alpha equals cosine beta because of periodicity, we have two cases. Either alpha equals beta plus 2k pi, or alpha equals 2k pi minus beta. So here k is an integer, whole numbers, I would say. All right, equivalently, this just means either alpha minus beta equals 2k pi, or alpha plus beta equals 2k pi. Now, let's go to our case. Let's do a case 1. Case 1, we have, say it's 7x minus 4x equals 2k pi, right? That means 3x plus 4x equals 2k pi. And then we have 11x equals 2k pi. If x, that means x has to be we can choose the k, right? So here we can choose the k all the way. X could go from at most x is 2 pi, right? X is 2 pi. So k could go all the way from 0 and to when x is 2 pi. That means k is 11, right? K can go from 0 to 11, those numbers. And here we have 12 of them. So that's one case. Case 2, we have 7x minus 4x. This is 2k pi. That means 3x equals 2k pi. Now, again, so x is in from 0 to 2 pi. And then we can have 3x is 2 pi. We don't need to consider k equals 0 because k equals 0 is already here, right? It's already, but that's x equals 0. So we don't have to consider. And then 3x equals 4 pi. And 3x equals 6 pi. But if 3x equals 6 pi, that's x equals 2 pi, which is already here. So then we don't need to consider this case, right? It says already counted. So the two new cases are here. That's x equals 2 pi over 3, or x equals 4 pi over 3. Accordingly, if we combine all the cases together, we get is there are 14 valid x. Question number 9. This is a problem about the inverse sine and inverse cosine. Let's first recall the definition of inverse sine, inverse cosine. So we have sine inverse x, or sometimes it's write as arc sine x. They're the same. Okay, so sine inverse of x, let's say theta equals sine of inverse of x means sine theta equals x. So it's the inverse function of sine. Here, of course, then the value of x is between -1 and 1. And then as a convention, the theta, well, in general, if sine theta equals a value of x, there are many choices of theta, right? Each time you add a 2k pi or pi over theta have the same value. Now, as a convention, in the definition of sine inverse, we restrict the theta in the range of from -pi/2 to pi/2. Okay, so this is important, and also should be careful when we handle inverse function, because there's fixed range. Cosine is similar, but except with a different range. Now, if cosine inverse of x, or we say the arc cosine of x, this one equals theta means cosine theta equals x. Now, again, x, of course, is always between -1 and 1, and the theta for inverse of cosine, we choose is from 0 to pi. We choose is theta from 0 to pi. Okay, all right. Okay, so now let's look at the function f sine inverse cosine and cosine x. And we look at several ranges. We look at the x is between 0 and pi/2. And then we look at what happens when x is between pi/2 and pi. And then we look at x from pi to 3pi/2 and x from 3pi/2 and 2pi to 2pi. Okay, now first let's look at what happens when x is between 0 and pi/2. Let's look at that. So first, if x is between 0 and pi/2, let's see what happens. And then my fx equals sine inverse. Okay, remember the cosine, because I want to change to something similar. So this one is just sine pi/2 minus x, and this is a cosine pi/2 minus x. All right, so this is just sine inverse. So this is sine pi/2 minus x, and then plus cosine inverse cosine pi/2 minus x. Let's look at this. So if this one equals theta, what does that mean? That means sine theta equals sine pi/2 minus x, and this one, okay, let's look at this one first. Well, meanwhile, we need theta is between pi/2 and 2pi/2. Now, when x itself is between 0 and 0 to pi/2, we know this guy is already in the from 0 to pi/2. Therefore, we can just choose the theta is the same as pi/2 minus x. Okay, so we get this one is pi/2 minus x. And here is similar. This guy is already in the range from 0 to pi/2. So we get this is also equals to just pi/2 minus x. Now, if we combine them together, we get is pi minus 2x. And if you look at x being the range from 0 to pi/2, which, well, we'll just get the range of this will just be between 0 and pi. All right. Now, let's look at what happens for case 2. Let's look at what happens. How about x between pi/2 to pi, right? Okay, now we have the same thing. We have fx equals sine inverse the sine pi/2 minus x, and then plus cosine inverse cosine pi/2 minus x. For here, well, we know it's sine theta, right? Equals to that, equals sine pi/2 minus x. Now, when x is in this range, pi/2 minus x, this will be between -pi/2 and to 0, and which is in the range of theta, right? In the definition of sine inverse. And that means tell us this one. Okay, so we can just choose theta equals to that. Okay, so this is just 2pi minus x. Now let's look at here. For this time, this one, we want to cosine, let's say this is beta, right? This is beta. So we want, okay, cosine beta equals cosine pi/2 minus x. But this beta, we want it to be from 0 to pi. Here, what we have, this one is between -pi/2 to 0, right? From -pi/2 to 0. Okay, then you say, all right, so then what shall we choose the beta? Now, let's look at this. This is the graph of the cosine x, right? Cosine x. And here is this. This is what we have. It's between from -pi/2 to 0. Well, you see, because cosine function is an even function, we can just put the point here, right? which means I can choose beta, is equal to negative pi over 2 minus x, which is the x minus pi over 2. But this one will be in the range from 0 to pi over 2, and which is in the range of 0 pi. Okay, so the point is, we just by careful get this one is x minus pi over 2. Now, what you get is this is pi over 2 minus x plus x minus pi over 2. What you get? You will get this one just equals 0. So the point is when x between pi over 2 and pi, right, we'll get this is the fx is constantly 0. Now let's look at two other ranges right here, right? Now from here to here, we know it's just x plus pi, right? That's how you go from the previous two situations to the next one, is add pi. So let's see the relations. Okay, so we say, what is the relation between fx and fx plus pi, so that we don't have to discuss each interval, right? Try to use some symmetry. Okay, so then we have this fx plus pi equals, right? Fx plus pi equals sine inverse cosine x plus pi, and plus this is a cosine inverse, this is sine x plus pi. And then let's recall trigonometric identity. We have sine x plus pi is negative sine x, and cosine x plus pi is negative cosine x, right? It's negative cosine x. Okay, this is negative. All right, so keep this one. So here is negative, negative, and therefore this should just get this negative. So, okay, so this is negative cosine x plus pi, and this is negative sine x plus pi. Okay, now let's look at the inverse function. What is the relation between sine inverse negative x and sine inverse x? Well, sine function is odd function, right? So sine theta is negative sine negative theta. So if x is between, and if x is between, say, negative, if theta, so if this is theta, then we get, if this is theta, then we get this one, which is negative theta, right? Negative theta is odd function, and the range does not change. They are both in the from negative pi over 2 to pi over 2. Okay, so then we get this one is just equal to negative sine inverse cosine cosine x. Sorry, here should be cosine x. This is negative cosine x. Okay, so cosine x. Now let's look at cosine. So here is negative sine x. All right, so now let's look at how about cosine. So what's the relation between cosine inverse x and cosine inverse negative x, right? Now, if this is theta, for cosine function, we know cosine pi minus theta is negative cosine theta. So, okay, so then if this theta, this just be pi minus theta. We need to keep the range. It's between 0 and pi. Okay, and we get this one just equals, okay, plus this is pi minus cosine inverse and the sine x. And then if you combine this together, we'll find fx plus pi, which just equals pi minus fx. All right, so this is what we derived. So fx plus pi equals pi minus fx. And therefore, the range for the previous two things, we get the range is between 0 and pi. And if you pi minus from 0 to pi, it's still 0 pi. Okay, so the final answer is from 0 to pi. That's the range of the function from 0 to pi. Question number 10. The problem says here we have square ABCD. M and N are middle points of BC and CD respectively. We need to find is the sine value of the angle theta that's between AM and AN. Here the point is, it's not so easy to find the sine theta directly because we do not have natural right triangle associated with theta. The key is to notice, if you look at two other angles, beta and beta, the two angles are the same because triangle ABM and AND, they are congruent. And we have the relation, the theta equals 90 degree minus 2 beta. Therefore, what is sine theta? Sine theta will just be cosine 2 beta. Okay, then the problem is to reduce to compute a cosine 2 beta. Now, compute a cosine 2 beta is quite convenient. That's because we can use double angle formula. Okay, let's use the double angle formula. Double angle formula, right? Cosine 2 beta, which equals 2 cosine beta squared minus 1, or equals 1 minus 2 sine beta squared. Now we can choose either one. The reason is we can very easily calculate cosine and sine beta. Okay, so let's say we put the side length of this to be 1, 2, and then bn will be 1. Okay, and then an will just be the square root of 5. And from here, we can quickly get sine beta, or let's say sine beta, right? So sine beta will just be 1 over the square root of 5. Okay, and then we just plug into here. We'll just get cosine 2 beta, right? Cosine 2 beta equals 1 minus 2 times 1 over the square root of 5 squared, which is 1 minus 2 of 5, and then we get is 3 over 5. Okay, so the value of cosine 2 beta is 3 over 5, which is the same as sine theta. Question number 11. The question says, for how many x between 0 and 2 pi, the following trigonometric equation holds? Right, so the equation says tangent x times cosecant 4x plus cotangent x times sine 4x equals 2. So here, let's notice what's the relation between these two terms. Okay, so we have cotangent x equals 1 over tangent x, 1 over tangent x, and the cosecant x by 4x, by definition, is a reciprocal of sine. So this is sine 4x. Therefore, if we consider this one as a, and then this number will just be 1 over a. Okay, so at step 1, we get is a plus 1 over a equals 2. And from here, we can quickly just get a has to be 1. The reason is if you multiply a on both sides, you get a squared minus 2a plus 1 equals 0. And then we complete the square, a minus 1 square equals 0. And this gives us a has to be 1. Okay, accordingly, the equation is reduced to, we have this equation, is reduced to the a, which is tangent x times cosecant 4x equals 1. And this says is tangent x equals, this is 1 over sine, so equals sine 4x. All right, so we need to solve. Basically, it's reduced to solve the equation tangent x equals sine 4x. Now, for things like this, we know a very useful tool is to draw a graph of tangent x and sine 4x, and then we just topologically compute the number of intersections, right? Okay, let's do it. Let's draw the graph of tangent x. We know tangent x is periodic, and the period is pi, okay? And it has asymptotes, which is pi over 2. Okay, so let's do this. Okay, so this is pi over 2. And here we have, this is pi, and this another asymptote, 3 pi over 2. Okay, and here is 2 pi. Okay, all right. Now let's draw the graph because we are looking at everything is from 0 to 2 pi. Okay, let's draw it. First, let's draw the tangent x. Tangent x as a symptom goes to this. So this is my tangent x. And then within here is this is tangent x, and then in this is tangent x. Right? So here we have 3 branches of the graph tangent x. Now let's draw the graph of sine 4x. We know the period of sine 4 pi, the period of sine 4 by 2 pi over 4, which is pi over 2. So that means within each interval of pi over 2, the graph will complete the graph of sine x. Okay, so what we have, let's draw it. We have this is the graph of sine 4x, and the graph of sine 4x, and the graph of sine 4x. Okay, we'll just complete all the period. Now let's just count the intersection. We have this is intersection 1, and this is 2, and this is 3. Okay, this is 4. And also you notice we say, okay, we have other intersections, right? If we just look at the intersections of, if we just look at this equation alone, right? Tangent x is sine 4x. We say, okay, you have things like this, right? So this is in the section, and this is also in the section, and this is also in the section. Okay, however, for those intersections, we'll get the sign 4x equals 0. However, when you look at, if you look at the cosecant x, this is not well defined, right? Cosecant x is 1 over sine 4x, so we do not allow. So this is not allowed. So those are not allowed. So we have to exclude those things. Okay, so the remaining is 1, 2, 3, and 4. So okay, so we have 4 valid numbers of x that fulfills the requirement tangent x times cosecant 4x equal 1. Therefore, the answer is 4. Question number 12. The problem says here we have isosceles triangle, which is ABC. AB equals AC. If the sum of height on the AB, which is here, plus the sum of height on AC equals the height on BC. The question is, what is sine angle B? All right, for this problem, what we can do is we can just transfer this geometric relation, the sum of two heights equal the sum of the base, into expression in terms of trigonometric functions. Okay, let's do it. This height, so okay, first of all, we use this height. If I use the angle A here, right? So this is the angle A. And then we have this one is just B times sine A. And this is the same. They are the same. It's also B times sine A, right? So AB and AC are the same. So I just use the same notation to B. And then if this is angle B, right? So if we did this angle B, then we get this height will just be B times sine B. And then we have the relation says this B sine A twice, or B sine A equals B sine B, and cancel B on both sides. We get equation 2 sine A equals sine B, right? And then the question is, how should we proceed from here, right? How should we solve the equation 2 sine A equals sine B? Because here we have two angles, A and B. So here the point is, what is A? A equals 180 minus 2B. And therefore, the sine A will just be sine 2B. Okay, so we replace, we just, okay, we get 2 sine 2B equals sine B. And then we apply the double angle formula, right? So we have, again, let's recall, so sine 2 theta equals 2 sine theta times cosine theta. All right, so then this one just 4 sine B times cosine B equals sine B. Now, because B is the angle of a triangle, so sine B is not 0, and we can cancel on both sides, and this gives us cosine B equals 104. And then we use sine B squared plus cosine B squared equals 1, and we get sine B squared equals 15 over 16. And again, because B is an angle in a triangle, so sine B is always positive, right? So we know the sine B is always positive, so we get sine B equals the square root of 15 over 4, and the answer is B. Question number 13. Here again, we have a triangle ABC, and we know the relation between side lengths. Here it's given by an algebraic relation by A plus B plus C, and A plus minus C is 5 over 2AB. And besides, we have a relation between the sine value, sine square A plus sine B square, sine C square. And the question is, what is the sine B? Now, here the point is, so when we look at things like this, we should think of the law of sine, because this basically tells us the relation between their side lengths. Okay, so if we recall the law of sine, right? So law of sine, so that's A over sine A equals B over sine B and equals C over sine C. And then if you plug into here, what you get, you just derive, you divide by sine A squared on both sides, so you just get 1 over 1 equals, this is the B square over A square plus C square over A square, and this tells us A square equals B square plus C square. Therefore, this is right triangle. Pythagorean theorem tells us, okay, this is right triangle. All right, and then you see what we want to find is the sine B, right? Sine B. Okay, now then we also have this relation. Let's write out. So we have A plus B plus C times A plus B minus C. This equals 502 times AB. And let's simplify this expression. So here we just get a plus b squared minus c squared equals 5 2 ab, and then we expand this out and move this one to the right hand side, to the left hand side, and then we just get a squared plus b squared minus 1/2 ab equals c squared. Now from here we have two ways to do. Method one. When we look at this expression, we quickly realize this just tells us the law of cosine, right? If we recall the law of cosine, the law of cosine says this. Let's recall the law of cosine. In general, let's recall the law of cosine. Law of cosine itself is a generalization of Pythagorean theorem. Right? So there we have, this is the say this is angle C. Let's say okay, so this is A and this is B, this is C. All right, this is the angle C. Okay, angle C here, angle C, big C. And then the law of cosine says a squared plus b squared minus 2ab times cosine C equals c squared. This is law of cosine. Now, if you compare the law of cosine, we quickly get, okay, so this is AB, this is AB, so we just derive the cosine C equals 104. Now, so we get cosine C equals 104. And what we want is sine B, right? But because A is 90 degrees, so cosine C is the same. So these two things are the same. So cosine C is the same as sine B. So we get a sine B is 104. So the first method, we just use law of cosine. Now, method two, we can do is we further simplify. Let's say we don't know law of cosine. Then we can also do like A plus B squared minus 1/2 AB equals C squared. But C squared is just equals C squared is just equals A squared minus B squared, right? So we will use the equation here. And this will give us, we cancel A from both sides. We'll get 2B squared equals 1/2 AB. And then we just get B over A equals 104. Right? We get B over A 104. But what is B over A? B over A is exactly by definition. So B over A exactly it's sine B. So again, we just get the sine B equals 1/4. Question number 14. Here says for closed interval I, we have Ni represents the maximum value of the function y equals sine x, and A is a positive number such that the maximum value within the interval 0a is twice of the maximum value between interval A and twice of A. And let's find all the possible value of such kind of A. Now, this is the graph of sine x, right? So first we know that A, we claim that A has to be bigger than pi over 2. You say, why it has to be bigger than pi over 2? Because if A is less than pi over 2, let's say this is A, right? If we say this is A, and then this will be from 0 to A, and the left, this is from, say, A from twice of A. But here says the maximum value from A to A is twice of that, right? It's twice of that. Which means bigger. If here the is positive, so bigger. But you see, if A is before pi over 2, the function is going up, right? So after A, it gets larger. So therefore, it cannot be the maximum cannot be twice of A. All right, so we get it has to be bigger than pi over 2. Let's say it's right here. Okay, so this is one option. So okay, say it's right here. So this is A, and then 2 of A will be somewhere like this. For example, let's say it's right here, right? For example, so this is 2A. Now, if you look at the interval, so this will be from 0 to A, right? From 0 to A, and the max of value of this will just be 1, right? The max of this is 1 because it already passed the pi over 2. This is the pi over 2 here. So the max of this one. And this, okay, so we just get the max from 0 to A, this is 1, and the max from A to 2A, right? So 2A, it has to be 1/2. Now, when you look at the graph, when you say, okay, if it's between here, let's say before pi, right? Before pi, if it's before pi, then in order to be 1/2, the graph itself is going down, right? It's going to negative. So in order to be 1/2, we must have the max is appeared here, right? So this is the max for this angle. for right here. So the graph is going down and go negative. So we must have the sine A equals to 1/2 for this case, right? So it's if A itself, say it's before pi, right? So if A is less than pi, but bigger than pi over 2, that's what we have. The sine A has to be equals to 1/2. And then this tells us that A equals 5 pi over 6. So this is first possible value of A is 5 pi over 6. Okay, well, but that's not the only option. We can also have the case. So this is, let's say, case 2, this one. We can also have case 2. Case 2, let's say if A is bigger than pi, right? So that's the case 2. That's if we have A right here. Let me erase this. Okay. If A is right here, so this is my A. And then twice of A will be somewhere here. That's what we have. So A is bigger than pi. Now, the point is it has to be less than. It has to be less than 3 pi over 2, because otherwise it will go beyond the 3 pi. It will go beyond 3 pi, and then you will get maximum value 1. All right, so that's impossible. We have to keep the maximum value is 1/2. Now, in order to have that, you see, this is a negative and all the way go up to here. So the maximum is right here. So this is the maximum one. Okay, and then we get the sine of 2A equals 1/2. And then we just get 2A equal 2 pi plus pi over 6. And from here, we get A is 13 over 12 times pi. And that's the only two options of A. If A is bigger than, if A is go beyond the 3 pi over 2, this is not going to happen, because the maximum one will just go beyond, will become 2. It cannot be, will become 1, but it cannot be 1/2. All right, so that's the only two options we have. Now let's add them up. So we have 5 pi over 6 plus 13 pi over 12. So we just get 12, and this is 13 pi, and this is my m, this is my m, so m plus n is 35. Question number 15. The problem says here we have this equality, 16 times sine 6 sine cosine 24, 78, and cosine x equals 1. And we figure out what is the least possible value of x. Now here we notice that 6, 24, 78, those are not special angles, right? So we cannot find the exact value of each of those guys. And then the common trick is maybe you can multiply, say, cosine 6. And then we use the double angle formula, go up. Maybe we can find a nice couplings. All right, let's do that. Okay, so we copy the equation. Let's copy the equation here. So we have sine 16. This is cosine 24. Sine 68, 78, and cosine x is equal to 1. Let's multiply cosine 6 on both sides. Okay, and then we notice cosine x and sine x, we use the double angle formula, and then we can borrow 2 from 16, so we get just sine 12, right? So let's recall the double angle for sine theta times cosine theta. This is sine 2 theta, right? So we use the double angle formula. And then this times cosine 24, right? We don't see obvious relation. But the point is that sine, and then we have sine 78. But sine 78 and 12, they put together is 90, right? So 78 plus 12 is 90. And therefore sine, this is just the cosine 12 degree. And then cosine x equals 1, or equals the cosine 6, right? Cosine 6. Okay. Now we can do another coupling, right? So cosine 12 times cosine 12, again, we borrow 2 from 6, from 8, and then we'll get a 4, sine 24 degree, cosine 24 degree, cosine x degree equals cosine 6. And then we just keep doing, right? Sine 24, cosine 24, borrow another 2 from 4. We just get a sine 2, sine 48 times cosine x degree. This one equals cosine 66. Now let's see what's the relation between cosine 6 and the sine 46. Right? And this cosine 6, this one we can just write as we can just write this as the right. So cosine 6, we know this one could be the same. We can write as 96. That's because we have the equality sine theta plus 90, or if you use radians power 2, this is the same as cosine theta, right? So we use this trigonometric identity. So they are the same. And then you say, oh, well, this guy just 2 sines is twice of 48. Okay, so we just we get so that's why we go to 96, because we realize 48. If you want to keep doing the double angle things, you get 96, right? So that's why we get the 96. So this is 48 times cosine 48, and cancel on both sides, and you get a cosine x equals cosine 48, right? Now what we are looking for is the least possible value of x, and obvious if the least value of x is 48. 48, then if you divide by 7, the remainder will be just 6 modulo 7. Question number 16. In triangle ABC, we know AB is 5, BC is 7, AC is 9, D is on AC with BD with 5. Find the ratio of AD to CD. Now, this problem itself on the surface, it does not involve trigonometric functions. Maybe there are some geometric methods to solve a pure geometric method to solve it. However, if we use the trigonometric function, especially the law of cosine, then there's quite a convenient way to solve this problem. All right, so we'll use the approach of trigonometric function, use law of cosine. So here the point is, this is angle C. We are going to apply the law of cosine on triangle BDC, and then on the whole triangle ABC. Okay, so we use the law of cosine to triangle BDC. Let's put it here. So to triangle BDC, BDC with angle C here, 7, and this is BD is 5. Okay, so this is 5. All right, so then we just get 7 squared plus the CD squared minus 2 times 7 times CD times cosine C equals 25. And then we apply the law of cosine to the whole triangle ABC. So we apply to A, B, C. This is 7, this is 5, this is AC 9, this angle C. Okay, then we get 7 squared plus the AC squared and minus 2 times 7 times the AC times cosine C equals 25. Now from here, well, we just want to solve what is AD and what is CD, right? Now from here, there are 2 ways to do. Method one, because I know the AC is 9, so it's okay. I put AC is 9, AC is 9. So from here, you can solve the cosine C. By this equation, you can solve cosine C. And then you put a cosine C back to here, we can just get the CD, right? So this is method 1. Method 2, we realize method 2, we can use a Vieta's formula, which is more convenient, right, as a shortcut. Now the point is, we realize both CD, AC, and AC, they are both equations. Okay, so we realize AC and the CD are both solutions to the equation. That's 7 squared plus x squared minus 14x times cosine C equals 25. So if we simplify that, we get x minus 14 cosine C and x plus the 24 equals 0. And then because both of them are solution to this, by Vieta formula implies AC times CD will be 24. Right? So the product of 2 solutions equals the C over that, which is 24. And from here, we quickly get CD is 24 over 9, right? Because we know this guy's 9, which is 8 over 3. All right, and then we just, what do we want to find? We want to find this AD to CD. And okay, so then we just get AD equals 9 minus 3, which is 3 to 19. And we get AD to CD equals 19 to 8. So here, the point is here, we have a nice example. If we use trigonometric functions, then we can solve this geometric problem in a quite robust way. Question number 17. The problem asks, in what interval does the smallest positive value x that satisfies the equation sine of this angle equals cosine of this angle? Now, first, let's recall when two angles alpha and beta. So we have two angles alpha and beta. If sine alpha equals cosine beta, what can we say about the relation between alpha and beta? Okay, so cosine beta is just equals sine pi over 2 minus beta. So here I use radians for convenience. Now, if we know that sine alpha equals sine pi over 2 beta, we know there are two scenarios. One is alpha equals pi minus 2 minus beta plus 2k pi, or alpha equals pi minus pi over 2 minus beta plus 2k pi. Okay, so they're equivalent to saying, from here, we'll just get alpha either plus beta equals pi over 2 plus 2k pi, or we have alpha minus beta equals pi over 2 plus 2k pi. Okay, the point is there are two different scenarios. Now here, if we consider my x is always between 0 and 2 pi, right? So here I restrict because all the options are between 0 and 2 pi. And then there's only two possible scenarios. The first one is if you consider this alpha, this beta. So the first one is you have sine x plus x over 4 plus cosine x minus x over 4, right? So alpha plus beta. Which, okay, maybe this one could be pi over 2. So that's one thing. And the second thing is I have sine x plus x over 4 and minus, right? Minus cosine x minus x over 4 equals pi over 2. Okay, the second one we can simplify sine x plus x over 2 minus cosine x equals pi over 2. Now let's look at the first one. The first one, x over 4, they just cancel with each other. And this one is equivalent to sine x plus cosine x equals pi over 2. However, the question is it possible I get a sine x plus cosine x equals pi over 2? Well, the point is this is impossible. Now, why is it impossible? Because let's look at sine x plus cosine x, right? Now, if we take the square on both sides, we'll get this is just 1 plus 2 sine x, and cosine x, as we did before, is 1 plus sine 2x. Therefore, the maximum one, this one is at most, is less than equal to 2. And this tells us sine x plus cosine x is always between negative square root 2 and positive square root 2. But if you look at pi over 2, what is pi over 2? So pi over 2 is like 1.5 something, and this guy is like 1.5 something. This is strictly bigger than square root 2, so that is impossible. So the first one is impossible. All right, now let's look at the second one. Is it possible we have sine x minus cosine x plus x over 4 equals pi over 2? Let's look at the function, which we say it's hx, that's fx. Okay, I put this guy as fx, and look at how the function fx changes. Well, we start from 0, and then we look at it from pi over 4, and then pi over 2, and that's the thing we are looking at, right? And then this is 5 pi over 4, okay? And now, this is, okay, here is, it's 3 pi over 4, okay? Now, this function f0, what is f0? f0 is equals to -1. So it starts from -1, okay? And here is, this is x, this is fx, it starts from -1. So this is -1. Now, if we look at, if we when x is between 0 and pi over 2, if x is between 0 and pi over 2, with a sine function, this is increasing, right? When x is between 0 and pi over 2, sine function is increasing, this is increasing, cosine function is decreasing, but if next sign is increasing. So that means when x is between 0 and pi over 2, the whole function fx is increasing, right? It's increasing function. Let's look at the value of pi over 4. So, okay, so we have, what is f pi over 4? Pi over 4, if I put there is a pi over 16, right? It's pi over 16, which of course is less than, so it's pi over 16 is right here. This is pi over 16. Now, what is pi over 2? What is f pi over 2? Okay, so we have f pi over 2 equals 1 plus pi over pi, okay. This is 2, this is 2, this should be 2. Okay, so here should be 2. All right, I have to correct it. Then this is not right. Okay, so this is pi over 8. So it's pi over 8. Okay, so this is pi over 8. Now f, this is 1 over 2 plus pi over this will be pi over 4, right? Pi over 4. Now, 1 plus pi over 4, this is right here, okay? So we have this one is the value of right here, it's 1 plus pi over 4. Now, for 1 plus pi over 4, this one is greater than pi over 2, right? Because pi over 4 is less than 1. All right, so the point, this is like pi over 2 is right here. So if I have a look at the graph of the function, so this, if this the graph of the function is like that, and pi over 2 is this right here. Okay, now this tells us somewhere, right? So we can, okay, we say somewhere between pi over 4 to pi over 2, we'll get a value, we'll get fx. So this fx equals pi over 2. So the answer is the smallest one we'll get is right here. It is between pi over 4 and pi over 2. Question number 18. Here we have a triangle ABC. It's an accurate triangle. A is, so this is A is BC, B is AC, and C is AB. O is the center of the circumscribed circle of this triangle. So let's draw it. Okay. Now N and M are distance. So this is center. Now N and N are distance from to AC, BC, and AB respectively. What here we need to find is the ratio between these three things. All right. Now we just use Pythagorean theorem. Let's write out. So what's N? Say this. Let's connect OB, OC, and OA. This is R. So R is the radius of this circumscribed circle. Okay. So then we have N. This will just A over 2. Okay. What is N? N is R squared minus A squared over 4. Right? You take the square root. Now let's try to simplify this. Let's see, okay, how we calculate. So here the point is how we calculate the radius of the circumscribed circle. Okay, here's the formula. Let's look at this. Say we have this is circumscribed, right? Here's A, here's B, here's C. This is the center, O. All right, so we have this is R. Now let's just extend this. Let me extend this circle, and we extend this and connect to this point. Let's say this is the point D. Now these two angles are the same, right? They're the same because they correspond to the same arc, and we know this guy is 9 degrees. Okay, and this one will be A. All right, so from here we get what? We get A equals twice of R, which is diameter, times the sine D, but sine D is the same as A. So this is 2R times sine A. And this tells us A over sine A is twice of R. Now, this is another way to express the law of sine. So we can, for the law of sine, we say, oh, wow, the ratio actually equals twice of the radius of the circumscribed circle. All right, so let me rewrite law of sine. Okay, it gives you one extra piece of information. It's A over sine A equals B over sine B equals C over sine C, and all of them equals twice of the radius of the circumscribed circle, right? So we write A equals 2R times the sine A. So I think that would be better. So okay, so we have N equals, this is the R squared minus 4R squared times sine A squared, and this is over 4. All right, so we just get this is R squared 1 minus sine A squared. Okay, so this guy we know it's cosine A squared. So okay, so when we express those things, we find this is just R times cosine A. Okay, so the point is we get expression of those three numbers N and M. So N equals R times cosine A, right? And then the N will just be equals R times cosine B, similarly, and the P is R times cosine C. Now, when you do the ratio, right, the ratio R just cancel with each other. You just get this cosine A, cosine B, cosine C, right? So here the point is we use Pythagorean theorem and plus relation, which relates the law of sine to the twice of the radius, right? The radius of the circumscribed circle, I would say the diameter. And now we plug into, we find, okay, we find a nice expression of m and n in terms of cosine values. Question number 19. Here we have an angle A that satisfies the equation 1 minus tangent A times tangent 3A equals 1 plus tangent A. And then we list the values of A in the increasing order, and we want to find the second one. All right, so first, let's try to simplify this equation. So this equation basically tells us the tangent 3A equals 1 plus tangent A and 1 minus tangent A. Then the point is whether we are able to simplify the one on the right-hand side, right? 1 plus tangent A, 1 minus tangent A. And for that, we need a sum formula, okay? So we need a sum formula of tangent function. So what's the tangent function? The sum formula is tangent alpha plus beta equals tangent alpha plus tangent beta 1 minus tangent alpha times tangent beta. Now the reason is simple because tangent alpha plus beta equals sine. Now this formula so far is not required in the AMC12, but I think it's nice to know it since the formula is quite elegant. And it's easy to derive because this is divided by cosine this, and we apply the sum formula, applying the cosine. This is sine alpha cosine beta plus cosine alpha sine beta, and this cosine alpha cosine beta minus sine alpha sine beta. Now, if you divide the numerator and denominator both by cosine alpha cosine beta and cosine alpha and cosine beta, and then you immediately get the equation tangent, get the sum formula of tangent. Okay, then if we compare this one and this one, we'll see if I choose the alpha is pi over 4, we know the tangent of pi over 4 is 1, right? So, okay, so we have tangent pi over 4 is 1, and then this one gives us is the tangent pi over 4 plus tangent A and tangent pi over 4 minus tangent of A. Okay, so this one, we apply this sum formula. This is just tangent pi over 4 and plus A. Now, then we basically just get the equation tangent 3 copies of A equals tangent pi over 3 and plus A. Now we recall the tangent function. The tangent function is a period. It's a 2 pi period, right? It's a pi period, and this tells us we should have is the pi period. We should have is 3a. 3a equals pi over 4 and plus a plus k pi, right? Plus k pi, and then here we have. Okay, so then we have the first one when k equals 0, that's we get is 2a equals pi over 4, and which is a equals pi over 8. And the second one, which because we try to list in increasing order, right? And then here we just get is the a, we get the a, k equals 1, and that implies the 2a equals 4 to 5 pi, and we get a equals 5 pi over 8. So the second one is 5 pi over 8, okay? And this is the n, and this is m, so m plus n is 13. Question number 20. The problem asks for how many x between 0 and 2 pi, the sequence cosine 2n x is negative. Okay, so we want it to be negative for all whole numbers n. So n start from 0, 1, 2, and all the way to infinity. All right, so let's look at the sequence. So sequence is the first one. So here we have the sequence. The first one is a1, which is cosine x, a2, which is cosine 2x, a3 is cosine 4x, and such and such. Now we want all the sequence, the an to be negative, is less than 0, and that's what we want. Okay, now obviously there's a relation between those terms because each one is the cosine of the double angle, right? So let's recall the double angle formula. So cosine 2 theta, we know it's 2 cosine theta minus 1. Okay, so based on that, here we have a relation is am plus 1 equals 2 am squared minus 1. Now we want each guy to be less than 0.
All right, so here we have a sequence with this given recursive relation. Now, a natural thing we should look at is whether it has some fixed point, right? Fixed point means it does not change. That means if we have something like a equals 2a squared equals 1, and you can solve this, you find if a is negative, we want a is negative 1/2. So the point is, if I start from a1 equals negative 1/2, then everything, all the other things, I'll just get a2 equals a3 equals a4, everything will be negative 1/2. And of course, that's less than 0, and which is what we want. Okay, so that's one case. We say, all right, so if a1 is negative 1/2, that means x equals negative 1/2. We have two choices. Either x is 2 pi over 3, or it's 4 pi over 3, right? Within 0 pi. All right, so at least we say, okay, we have two of them, right? Okay. And the question is, how about, do we have more? Right? Besides x equals 2 pi over 3, 4 pi over 2, this is special, right? Everything is negative 1/2. Do we have more? All right. Okay, so let's see. The answer is no. That's all we have. We don't have other possibilities. Now let's see why. Okay, so if we have an plus 1, let's recall, so we have this an squared minus 1. Because we know negative 1/2, this one is special. It's we call a fixed point. Since the sequence will, if you start from negative 1/2, everything remains as negative 1/2. That's a fixed point, right? And then from here, you have an plus 1. Let's look at the difference. So plus 1/2. This one will be negative, right? It will be negative. This is the an squared minus 1/2. So that's twice of an squared minus 1/4. And we can factorize this. This is twice of an plus 1/2 and times an minus 1/2, right? And then we get plus 1/2. This equals twice of an minus 1/2 times an plus 1/2. Now, what's the point? The point is, when you look at this, you say, this an is negative, right? So negative minus 1/2, this one will be less than a negative 1/2. So it's multiplied by 2. It will be less than negative 1. So that means the recurrence, if I put a 1/2, if this one is not 0, then it's just go up by a factor, right? Go by a factor, and it will go to and get larger and larger. But that is impossible since an. Remember our an is less than 0, but is bigger than negative 1. So it cannot get too large. But anyway, let's make this rigorous. Now I claim each an has to be less than negative 1/4, right? So 1/4, I just choose a number that is nice. I mean, you don't have to choose 1/4. But okay, now let's say if not, let's say an is bigger to negative 4, but of course it has to be less than 0. Then let's look at the next term. So n plus 1 will be twice of an squared and minus 1. This one will be less than, because at the most you put it here, right? But then it will be a 1/8 minus 1, which is negative 7 over 8. So the point is, if one term is no less than negative 1/4, the next term will be less than negative 7 over 8. And then it's okay, what about this? Then look at next term. This is twice of an squared and plus 1 squared minus 1. And this one will be greater because this is less than negative 7 over 8. So 2 times 49 over 64 and minus 1, right? And then you see this is 32, right? 32. And then this is positive, because positive, which is not what we want, right? So this is not what we want, because we want each term to be less than 0. Therefore, we just get each one has to be less than negative. So this is correct. Then if we put it here, we'll get, if I take the absolute value, we say, okay, if I take the absolute value of the whole thing, this will be the absolute value of twice of an minus 2 and times the absolute value of an plus 1/2. Now then this guy, if I use the an less than 1/4, this one will be, I take the absolute value, right? So the absolute value, so the inside will be less than negative. So this is 1/4, so for 3, okay, will be less than 2, 3. Okay, so it will be greater than 3/2 times this an plus 1/2, right? Plus 1/2. And then you will see, okay, which means each time you go up by at least 1.5 times. And this tells us if you say, okay, we get a recurrence, we just get an plus 1 plus 1/2. This will be greater than 3/2 to the power n and a1 plus 1/2, right? a1 plus 1/2. Now then, if this guy is not 0, which means if this one is positive, and this guy will be go up all the way to infinity, go up to the infinity. But that's not possible since this guy is at the most, it's between 0 and -1, right? And if you put it together, this quantity is at the most, right? So this quantity is at the most, it's 1/2. So it cannot go to infinity. Therefore, you must have the starting point, it has to be 0. Otherwise, it just shoot out of the roof, right? Okay, so then we just get a1 has to be -1/2. Then we know this is a fixed point. Everything has to stay as -1/2. Okay, so the conclusion is you have to start from -1/2, and then everything is -1/2. You have two choice, 2 power 3 and 4 pi over 3.